In example 1, we want to complete the square on f of x equals x squared minus 4x plus 1. So I'll just jot that function down again. So that's x squared minus 4x plus 1. And our goal is to create a perfect square. So I want something of the form x minus a number squared, and then there'll be plus, some other number at the very end. So I want to change the formula from this expanded form to something factored in this particular way. So I'll go through a really simple procedure that will do this for you, but what I'm going to do is use this -4 to generate a couple of new numbers. I'm going to take half of this number, which gives me -2, and then I'm going to square this -2, which takes me to a +4. All right, well, to create a perfect square, I'm going to add this 4 after the -4x, which will create a perfect square. Let's see what that looks like. F of x equals x squared minus 4x, and I'm going to put in this +4 into my equation. These three terms are now a perfect square. However, if you add in a +4, you've changed your equation. So what I'd like to do is this little trick where if I also subtract 4, the equation I wrote is equal to the one that I started with. So the reason for that is if you add the 4 and -4, they cancel, taking you back to the first equation. Okay, so the second step is these three terms are now a perfect square. Let's figure out what that is. That is f of x is equal to, well, it's got to be x minus something squared. And actually that something is this other number that we generated, this -2. And if you check it out, if you square x minus 2 squared, it'll give you an x squared. Squaring a -2 will give you a +4. But you get two middle terms. You get -2x, you get a second -2x, which gives you this -4. The last step here would be to now combine the -4 and the 1, which gives us -3. And that's it. This is completing the square. So to recap, you need a couple of numbers to do it, and it's going to come from half of the number in front of the x term. You get that number and square it, and they both appear within your final answer. So the second part of this question is to actually sketch a graph of this function. Writing your equation as something in a completed square is nice because it tells you how the graph works by transformations. So by that I mean, if we take the graph of x squared and we go 2 places to the right, and then we go down 3 places, I'll have the graph. So I'll start with the point 0, 0, which is the vertex on my original graph, and I'm going to move that point 2 places to the right, and then down 3 places, which is 1, 2, 3, which is here. That's 2, -3. So I'm going to mark that new location, and the rest of the graph is going to follow along. So I'll sketch that in as best I can, but it looks something like this. So I won't draw on the whole thing. Really, it's just to get an idea of what the graph looks like. So the new vertex is at 2, -3, and writing your equation in this form makes it very easy to visualize without actually plugging it into a graphing calculator. So for the second example, same idea. I want to complete the square on this quadratic. We won't worry about the graph. Maybe at the very end we'll actually state where the vertex is located. This example is a little bit different because the number that's in front of the x is a 5. So if we divide it by 2, it's not going to be an integer anymore. You could either use a fraction or a decimal, so we'll just decide as we go which we want to use. But I'm going to start this the same way, where I'm working with the function f of x is equal to x squared plus 5x minus 7, and off to the side I'm going to jot down the 5, and I'll take half of it. I think I'll use a decimal for this problem. So half of 5 is 2.5. And if you square 2.5, you get 6.25. Okay. These are all the numbers I'll need to put in my equation to complete the square. So let's see what that looks like. What I'm going to do is, after this 5x, I'm going to add in 6.25. But I'm also going to subtract 6.25 so as to balance the equation. I have f of x is equal to x squared plus 5x, then I'll put plus 6.25 as well as minus 6.25, and then put the minus 7 at the end. Clearly this equation is equivalent to the first one. But these three terms are now a perfect square, so let's set up what that should look like. F of x is equal to, okay, it's going to be x plus something squared this time, and at the very end I can combine these two numbers, so I have negative 6.25 and negative 7, that's negative 13.25. So all I have to do is figure out what is the number that goes in place of the parentheses here. And it's the number that when you square it, it gives you 6.25, and when you double it, it gives you 5. That is this other number, which is 2.5. And that's it. I've completed the square on this expression. And it's worthwhile to look through why this is correct. But let's see. If I square this thing out, you get an x squared. Squaring 2.5 does give you 6.25, and you get a 2.5x, you get a second 2.5x, which gives you 5x. Everything else I did was just take the two numbers at the end and combine them, and that's it. So I'm convinced that this whole equation is equivalent to the one that we started with. Maybe I'll just note about what the vertex is. What's the vertex of this equation? And I can use transformations to figure that out without even looking at a graph. That is, okay, I'm going to go 2.5 places to the left, but then I'm going to go down 13.25 places. So that is, the vertex is negative 2.5, the opposite, but then for the y value, it's negative 13.25, which is what you expect. And like I said, you can go through this problem using fractions. Like, instead of using 2.5, you could have left it as 5 halves. And instead of using 6.25, you could have used 5 halves squared, which is 25 fourths, and your answer would look a little bit different, but it would really be the same thing. It would just have a 5 halves here, and then some other fraction at the very end. So you can use either one that you like, but both will take you to the same equation. And for the last example, same idea. I want to complete the square, maybe locate where the vertex is, but there is something slightly different with this one where it's a little bit more difficult. Here's the thing. There's a 2 in front of the x squared. In examples 1 and 2, there was just a 1 that I didn't even write. And anytime that you put a 2 here, you cannot simply just take half of this number and square it and start working through the process. You have to somehow remove this 2 from the question. So I'm going to show you my way of doing it, where I factor it out from the first two terms, but there are other ways to approach this as well. So the process will be really similar. I'm just going to put an extra step in here where I'm first going to factor a 2 out from just the first two terms and go from there. So let's see what that is. I have f of x is equal to, okay, if I factor 2 out from just the first two terms, you get x squared and you get 9x. Clearly these two things are equivalent because if you distribute the 2, it'll take you back to the same equation. Okay, but at this point, I'm now going to ignore for the time being the 2, and I'm going to ignore the negative 1, and I'm just going to try to complete the square on this portion in the parentheses because there's this 1 in front of the x squared, and I have a nice process for figuring out how to complete the square on this. I'll have to do a little trick at the end to balance my equation, but it won't be very difficult. So what I'm going to do is take the 9, and I'm going to take half of it, and again I'm going to use decimals, but you get 4.5. I'll then square 4.5, and we get 20.25. All right, now we're good to go. I'm just working for the time being inside the parentheses. So I have f of x is equal to 2. All right, I have x squared plus 9x. Okay, I want to add in a number that creates a perfect square. From our previous work, I know that's 20.25. So by putting that 20.25 in that spot, I've created a perfect square. But unfortunately, my equation is no longer balanced. I just added in a number that wasn't there. I want to put something at the end. I'm going to subtract something so I can balance my equation. But the question is, well, how much do you subtract? Well, last time we just subtracted the number itself. But unfortunately, this is not what you subtract. It's really close, but it's not quite right. It should actually be 2 times this amount. Why does that happen? It's because of this 2 in front of the expression. When you put 20.25 here, this 2 gets multiplied to it. So it's actually putting in twice as much of this thing, which is why I'm subtracting twice of 20.25. So let's clean this up a little bit. I have f of x is equal to 2 times x squared plus 9x plus 20.25, and then I have minus 1 minus doubling 20.25. So that would be 40.5 minus 41.5. The last step here would be to complete the square on this portion, but I know it's going to involve this 4.5, so I'm simply going to write it out. F of x is equal to 2 times x plus 4.5 squared minus 41.5. And you could check your work again to make sure this is true, but okay, well, if I square x, I get x squared. If I squared 4.5, I get 20.25. And if you double 4.5, you in fact get 9. So technically this is it. Again, if you wanted to maybe state what the location of the vertex is, it would be negative 4.5 for x, but negative 41.5 for y. And that is it for this example.